Welcome to Homework Lib.
Chapter 14, question 118. They give us a reaction, and I'm just going to write the important part of the reaction, which is C2H5I, and this is going to be an aqueous solution, plus a hydroxide, which then they will tell us this guy is coming from potassium hydroxide. And that will give us some products, which is for now not important. Now at A, they're asking us predict the rate constant for the reaction at 35 Celsius. Now our formula is K equals to frequency times e to the power of minus activation energy divided by RT. Now the important things to know here is this activation energy is in joules, and R is going to be 8.314 because this unit is going to have joules in it, and RT is going to be in Kelvin, which is basically 273 plus the Celsius. So now if you just simply put the values they give us, what we're going to have is going to be 2.10 times 10 to the power of 11 e to the power of, now this is going to be, they give us the activation energy in kilojoules, so we need to convert it to joules by multiplying by 1000. 86800, this is going to be in joules, and divide by 8.314 times 273 plus 35. And then the answer here going to be 0.00039, which is around 0.0004. Now at part B, what they're asking us is a solution is made of KOH dissolving in ethanol, and they give us the grams for KOH. So what we need is to convert all these to the concentrations. So concentration is basically number of moles divided by the volume, and this volume is in liters, not milliliters. To find the number of moles, what we need to do is to divide the amount of potassium hydroxide we have by the molar mass of the potassium hydroxide that we can find from the periodic table. That is 56 grams per moles. And if you do that, you're going to get 0.006 moles. And if we get this guy in here to this equation and use 0.25 for the liters, because they give us 250 milliliters, then we're going to get molarity of KOH will be equal to 0.024. And similarly, we're going to use the same equations to find the molarity of C2H5I. Now, the C2H5I, they give us 1.453 grams. And using the periodic table, we're going to find the molar mass of C2H5I is 156. That will give us number of moles 0.0093. And if we simply, I'm sorry, that's going to be 93. And if we simply divide 0.0093 by 0.25, then we're going to get 0.037 molarity. Let's write it here too, 0.037. Now at part C, they're asking us which reagent is the limiting reagent. So you need to think about this equation again. This is a one-to-one equation. For every 1 mole of this guy, you spend 1 mole of potassium hydroxide. So we have 0.024 in concentration over here, and in the same flask, so the same volume, we have 0.37. If we consume this guy all the way up, we're going to have some excess amount over here. And that excess amount means our limiting reagent is potassium hydroxide because this is consumed all the way. So the answer to C is going to be KOH. And for part D, they're asking us to use the same equation that we use at A, only that we need to change this part to this time 273 plus 50 Celsius. And if you do the same calculation again, what you're going to get is 0.00192.